Prasada, what we'll do is remember we did comparison of hydrolysis, TK, of fluorine related compounds. So I'll just do a couple of questions. And then we can start with, okay, I'm going all the way back. Just one second. Just a second. See this one. So last time we did hydrolysis comparison. Okay, chlorobenzene, no hydrolysis. This had no hydrolysis. This had SN1, SN2 reaction mechanisms, and the acyl chloride had vigorous hydrolysis. Okay, so just a few questions. Okay, and just one second. So I'm just going to do equality. Page 36. I'm just going to do a couple of questions. Okay, show you कि किस तरह के questions आते हैं. 36. Okay, so you can see it's exactly the same question. Okay, what he's saying is explain the relative rate of hydrolysis of acyl chlorides, alkyl chlorides, which is basically halogenoalkanes, and aryl chlorides, which are basically chlorobenzene. So slowest is chlorobenzene, which is aryl. Remember arenes or aryl that's used for benzene. Acyl chloride is the fastest. And the middle one is your alkyl chloride or your halogenoalkane. And the explanation for that is what's wrong with benzene? Okay, why do chlorobenzenes not getting hydrolyzed? So the explanation for that is that if you have Cl that's attached to it, let's if you have a Cl that's attached to it, the Cl lone pair, it's got a lot of lone pairs. They kind of overlap with benzene's pi-electron cloud, which is why the amount of electrons that you have in this area are a lot. So the wording, we did that last time. Cl lone pair, it overlaps with what? With benzene's pi-electron cloud. So CCl bond strength increases. It increases and it has higher charge density. And it repels nucleophiles, which is water. Which is water, because water was the one that was the nucleophile. So hydrolysis will not happen because the water molecule and its negative charge and its lone pairs are not going to be attracted to the high electron density CCl bond. So there won't be any reaction. And vice versa, you can talk about. Simultaneously, what you can do is you can talk about the other one, which is acyl chloride. Why do they have strong hydrolysis? Maybe it's double bond O and Cl. So this Cl, the carbon is bonded to two highly electronegative atoms, which is why the carbon has a very strong positive charge. And your water nucleophile is very strongly attracted to it. Okay, so C in RCOCl is bonded to 2. very electronegative atoms, and you can name the atoms. You get the atoms are oxygen and Cl. So it has large partial positive charge density. And it attracts nucleophiles very strongly. Again, you don't remember you always have to explain the extreme cases, not the middle one. You can, I mean, there's no point writing for the middle one. Okay, that's your 3 marks. ये clear है? Hala, Minal, Ibrahim, is this clear?
Yes, sir.
Yes.
So, this one, chlorobenzene and chloroethane. One is a halogenoalkane, the other one is the chlorobenzene, which is not going to undergo, उसने लिखा हुआ है, they have different reactivities in nucleophilic substitution. Identify a suitable reagent to illustrate this difference. So the suitable reagent is ये जो halogenoalkane थे, that was NaOH aqueous and reflux. So identify a suitable reagent to illustrate the difference in reactivity. The reagent chosen should give a visibly different result. Because of this, we would have to, okay, I'm going to add this over there as well. Remember, the reactions are with water. So for a visible result, especially if you want a visible result, the reagent is, because they're all chlorine-related compounds, what you do, you add silver nitrate aqueous. Because remember, in all the cases, if they react with water, Cl lines are going to be produced. Okay, the Cl lines, it's aqueous, right? So Cl lines produced due to hydrolysis will form a white precipitate. So what will happen is that if you add water or silver nitrate aqueous, that already has water. So the Cl lines over here are not going to get knocked out. So there's no hydrolysis, Cl lines are not produced. So silver nitrate cannot react with these Cl lines, and it will not form a precipitate because Cl lines are not produced. Over here, some hydrolysis will happen, a slow hydrolysis will happen. Water will come in, the carbon is positive, the Cl is negative. So Cl lines will get knocked out, and you will get some precipitate of AgCl forming, but at a slow rate. Over here, the carbon is very strongly positive. So the Cl is going to get knocked out, and the nucleophile will be very strongly attracted. So it's going to form a precipitate very, very quickly. Okay, so I've added this point here for a visible result, especially for chlorine-related compounds. I mean, silver nitrate aqueous is water, but the additional silver nitrate will produce a visible result. ये बात clear है? Is this clear? Ishaq, Khala, Minal, is this clear? Very clear?
Yes.
Okay, so write equations to describe any reactions that occur. So they do occur for chloroethane. Ethane is 2 carbon atoms, so it's CH3, CH2. Cl, since it's aqueous, there's going to be OH ions which are going to knock out the Cl ions. So you will have hydrolysis, and you will get Cl ions. The Cl ions will then react with silver ions to form AgCl white precipitate. Okay, so that's your hydrolysis that will be happening. But with halogenoalkane. Explain the difference in the reactivity of chlorobenzene. So he's talking about the difference. So it's the same explanation that which is given over here. Okay, why does the chlorobenzene not react? Because the lone pair on Cl, it overlaps with benzene's pi electron cloud, increases the CCl bond strength, and there's more electrons over here which are going to repel the nucleophile. Whereas in halogenoalkane, the carbon will have, halogenoalkane doesn't have a double bond, oh, that's the only difference. So the carbon, I mean, the explanation would pretty much be the same. The carbon will have a positive charge and it will attract nucleophiles, although not as strongly as an acyl chloride. And so then you're given these compounds and you think, name the mechanism, he says cyclohexylamine reacts with ethanol chloride to form the corresponding amide L. And let's see, this one we haven't done, so we can sort of ignore this. Lone pairs and curly. But we have done this. This is let me explain. Okay, we did a mechanism for acyl chlorides, which was nucleophilic addition elimination. Okay, so what I'm going to just add, because nitrogen compounds we haven't studied yet. So we had this mechanism of water as a nucleophile attacking this carbon positive, right? The lone pairs were getting attracted to this carbon positive and the double bond electrons were getting repelled. So the double bond electrons, they ended up at the top. The oxygen bonded with the carbon. And those lone pairs, they came back, formed the double bond, and the Cl got knocked out. And you had this entire mechanism. Remember, this entire mechanism would be exactly the same with amines as well. So I'm just going to write, although we haven't done nitrogen compounds yet, but with water, with NH2, it's going to be exactly the same, because that is a nucleophile that's very similar to water. So if you have a look at this question again, it's the exact same thing that's happening. So name the mechanism that's nucleophilic addition elimination. So addition, remember, it's the reaction mechanism of an acyl chloride. And they're asking you to write the mechanism for this reaction, and you have to tell the products as well. So the N has lone pairs. The carbon over here is very strongly partial positive. This one is going to be attracted to this carbon over here, and the double bond electrons are going to be knocked upwards. And you will have CH3, and you will have CO minus 1. The double bond electrons have been knocked upwards. There is Cl. And this N at the bottom has now, with two H's, has now bonded with it. And this N is going to be positively charged because it lost its lone pairs. The oxygen at the top is going to come back, and the electrons in the CCl bond are going to be knocked out. Okay, so I mean that's it. They've already just written products, so I think you don't have to draw the products. But the product is going to be like, if I draw it, I don't think that's required. So what's happening is the double bond reforms, and now you have N with H's and an R, and this N doesn't have a lone pair. And the Cl gets knocked out. And that Cl is going to come back, and this So this Cl is going to come back and it will steal the H. And that H will give the bonded electrons back to N, so N gets its lone pair back again. Because that's the entire mechanism. So I don't think you had to draw the products. Pretty much that's it. ठीक है तो ये भी clear है. Is this clear that this complicated nucleophilic addition elimination reaction mechanism?
Yes, sir.
ठीक है तो ये याद रखना कि it's not just with water, it's with amines as well. And normally what they can do is they can give any nucleophile. ठीक है, just to play around with this. अच्छा फिर I think I mean this is we haven't done. Again, it's exactly. I mean this is exactly the same mechanism. Lone pair, carbon is positive. These two are negative. The lone pairs over here, the double bond over here. Okay, then you know the rest. Name the type of reaction mechanism that's nucleophilic addition elimination. And again, make sure if you look at this carefully, he's talking about addition elimination mechanism, right? That is for an acyl chloride. Now, if you look at this compound carefully, one section of this compound is an acyl chloride, which is this one. It's a acetyl bond O with a Cl. The other portion is a simple halogenoalkane where you have a carbon which is bonded to a carbon with H's which is bonded to Cl. So, I mean, the rest is pretty much the same. It's this carbon is positive. Remember, it's not going to get addition elimination happens with acyl chlorides. So this is going to get attracted to the carbon positive. The double bond is going to get knocked out, and the rest is kind of the same. So remember this, addition elimination happens with acyl chloride, not with the halogenoalkane. Okay, you should have the ability to differentiate between the two. ये भी clear? Ibrahim clear, Saak, Middle, Qasim, is this clear?
Yes.
Yes.
So explain why this can act as a nucleophile. Well, it can act as a nucleophile because it's got a lone pair. बस यही है और एक मार्क में क्या होगा? ठीक है, it's got a lone pair. ठीक है, so that's it. So okay, इधर क्या कह रहा है कि नहीं, this is about polymerization, so we can. This is exactly the same. I should remember one thing, that benzene C6H5 is benzene. This is benzene with a Cl, so it's exactly the same question. Chlorobenzene, no hydrolysis. Acyl chloride, very vigorous hydrolysis. Chloroalkanes, moderate hydrolysis. You would have to heat it with NaOH aqueous and reflux. And you have to explain the relative rates of hydrolysis. तो अब आ जाते हैं acids पे, ठीक है? अच्छा, now this is a new section. ठीक है, so this is comparison of acids. अच्छा, एक चीज याद रखना कि I'm teaching you the way things are going to be asked. For example, the chlorine-related compounds, there were 3 separate chapters. But in the past papers, you'll be asked things together. Okay? So इस तरह acids में ना, we'll talk about phenols, we'll talk about alcohols, we'll talk about carboxylic acids. They're 3 separate chapters, but the question is always going to be exactly the same. It's going to be the comparison of acids, so I've grouped those things together. As a comparison of acids, first thing is how many acids you've got? You've got alcohols. Okay, so for comparison, we're keeping water. Then we have phenols. So we've got phenols or and the last one is carboxylic acids. Now, relatively speaking, alcohols are the weakest. Okay, so we're going to talk about the strength of acids. So, लिख भी देते हैं नाम नीचे. This is alcohols. This is phenol. And this one is a carboxylic acid. Okay, so you've got three different categories of compounds. Water is for reference. So, and the trend is that the strength of the acids, they increase when you move to the right. This one is the weakest ionization. And this one relatively is the strongest. They're all weak acids. So the carboxylic acid has the strongest ionization. I said then the reactions, just to summarize the reactions first. So number one, with इसको अगर हम कर लें, अच्छा चलो ठीक है. Need one more. I said now comparing between these three. Start with the first one. You will have a reaction with the sodium. So they all react with sodium. All of them are going to react. Even water will react. And what is the reaction? What is the product that's going to be produced? It's going to produce the alcohol is going to produce CH3CH2, O minus 1, Na plus 1, plus hydrogen gas. Okay, that's what's going to be produced. And the name of this compound is going to be sodium ethoxide. ठीक है, नाम लिख लेते हैं sodium. Ethanol will produce ethoxide plus H2 gas. Water will obviously produce NaOH plus H2 gas. Phenols would also react, and phenols are going to produce a phenoxide. So you got a phenol, and that phenol will react with sodium metal. It will lose its H, and you will have a -1 charge and Na plus 1. So this is sodium phenoxide. Plus H2 gas. And finally, you had this ethanoic acid, which will also react. And your ethanoic acid will produce a salt. So that's sodium ethanoate. Neat propanoate, okay. There's an extra carbon. I have to remove that. नहीं कर लेते हैं. अच्छा, so okay, this one is sodium ethanoate. You can remember carboxylic acid, that's going to be ethanoate plus H2 gas. So the point is that they all react with sodium metal. All of them are going to react with sodium metal. Okay, that's number one. Up number two, जो है ना, that's ये clear है, sodium metals, they're all going to react. Is that clear? Qasim, Isaac, Ibrahim, is this clear? Ala?
Yes.
So they're all acids. Alcohols are behaving as acids. They're all losing H plus one ions. Remember acids. What's an acid? It's something that is a proton donor. Okay, so they're all losing their H plus one. And remember, it's a redox reaction. The H plus one gains electrons, and Na is the one that loses electrons. Na becomes Na plus one, H plus one becomes H2. As the second reaction is with NaOH. So what happens when they decide to react with NaOH number two, which happens to be a strong base? I say in this case, what happens is that the first one does not react. Alcohols don't react. So no reaction. I'm going to exclude water because NaOH also does not react with water as well. Phenols do react. Carboxylic acids do react. And you kind of pretty much get the same exact thing. ठीक है, तो वही copy कर लेते हैं नीचे. So you're kind of getting so you're kind of getting the same thing, with one difference that it's not going to be H2 now that's going to be produced. It's going to be water that's going to be produced. Okay, so you'll get the exact same. You're going to get the exact same salt, but metal hydroxides they produce. So they produce. अच्छा, इसमें they produce sodium hydroxide. ठीक है, एक सेम का together. ठीक है, कासिम ये मैं भेजता हूँ. ठीक है, क्लास स्कैन पे. ठीक है, क्लास स्कैन पे मैं सारी भेज दूंगा. अच्छा, finally, there's a third one. This one was a strong base. Then there's a third one, and the third one is sodium carbonate. ठीक है, who reacts with sodium carbonate? Carbonates are weak bases. Now, in this case, what happens is that alcohols don't react because they're very bad acids. Phenols even don't react. The only one that reacts with a carbonate is a carboxylic acid. So carboxylic acid is the only one that's going to react, and it will produce water plus carbon dioxide. So collectively, the point is Okay, we've got four types of things that are behaving as acids. And in those four types of things, the alcohols are the least acidic. They don't undergo most acid reactions. They just react with sodium metal. Otherwise, they don't really react with any of the other ones, the strong bases and the weak bases. Your phenol over here, you get this is slightly stronger acid. It reacts with sodium metal, it reacts with strong bases, but it doesn't react with weak bases. And the last one is carboxylic acids. They pretty much react with all, whether it's a strong base, whether it's a weak base, they are going to react. ठीक है तो सबसे let's just put सेट करते हैं एक सेकंड अच्छा उसकी रीजन पे we'll discuss ठीक है at the moment what you need to know is so at the moment what you need to know is that alcohols are like terrible acids, carboxylic acids are really good acids, and phenols are kind of in the middle. ठीक है, is this clear? Middle clear है?
Yes.
So let's go. So this table is very important because they're going to ask you a lot of questions on this. Okay, just the fact that carboxylic acids are like really good acids and alcohols are like really bad acids. And they're going to ask you about the products, okay? So carboxylic acid is going to form sodium ethanoate in all cases. Phenols will just not react with weak bases, and alcohols pretty much don't react. So now early class में we'll discuss the reasons for each one of them. Okay, why are they strong? Why are they weak? ठीक है? तो next class में continue करते हैं, ठीक है?
Okay, sir. Allah.
Okay, Allah Hafiz.